Welcome to Unit 3 of the SAP HANA Introduction course. This unit will deal with data provisioning, providing data into HANA. First, we're going to look at uploading data from flat files. Then we're going to look at data services. We're going to go on to see about LT replication server and also the direct extractor connection in the DXC. So HANA doesn't actually come with any data. It needs to be populated somehow, just like any database. Replication is one of the methods. We could then have data from a source system replicated in our database. Replication can mirror it, or it can be transformed. Data can be transformed in the process of replication. So there's different technologies of doing so, different methods. Let's look at some of them here. When we talk about replication here, we see the flat file upload. The flat file probably doesn't provide replication in a delta fashion, but I guess you could call it replication by stretching the term slightly. The more talk about the traditional types of replication, we can see trigger-based replication from perhaps an ERP system or any other database. We could have ETL-based replication, scheduled replication that would be within intervals. We also have log-based replication, which could be real-time. So these are different types of technologies. Let's start looking at how we would go about uploading data from a flat file, probably the simplest way of putting any type of data into HANA. So if we see what we're going to learn here, after completing this lesson, we should understand the capabilities and positioning of the flat file data load functionality. We should be able to load data from flat files into the HANA database. So there's a new feature in SD4 of HANA that's uploading data from flat files. Why would you want to do that? Well, it could be that you want something simple to start with. Maybe you're doing a proof of concept. It could be that you want static tables in HANA that's not really going to change. It could be files that don't actually exist in a database. Maybe you've sourced them from somewhere else. Maybe you've been given these files from an external provider. It could, for example, be pricing information. Let's say it's a stock exchange or a commodity trading system or something. It could be market rates in this type of fashion. But to load this type of data, it's first necessary to create a table structure that is based on the flat file. The application itself will suggest the column name and data types for the new tables. We're not happy with them, we can edit them. Now the new table will always have a one-to-one mapping between the file and the table columns. When loading new data in the table, it will get appended to the existing data. We already have it. Now the application doesn't allow overwrite of column or change the data of existing data. And what we support, CSV, comma separated values, XLS, Office, XLSX, the new type of Excel for Microsoft. So to the overview of the process flow, how we'll go about uploading data into HANA from flat files. We'll first select an import source, select a target, we select the actual physical file, and select which target table it should go into. We'd manage the table definition and data mapping. Finally, we'll check the target table so that it looks presentable. So we look at these steps in more detail on how to use the Studio for this purpose. To select the import source in the file menu, we choose Import, and we'd go on and expand the HANA content directory. And in here, we do have an option to say data from local file. This is the one we want to use for a flat file upload. Then we click on Next. So the next window would give us an option to choose the target system. Remember, in HANA Studio, you could have more than one system that you're maintaining or developing against. So you'd have to specify which of these databases should be imported to. So if we choose one here, we click on Next, we know where it's going to go to. The next step would then be to select the actual file that we want to upload. So we would browse for the file, the source file there, and if we've selected, for example, a comma-separated value file, we would have to choose what the delimiter is. It could, for example, be a comma, it could be a semicolon or a colon. If we've chosen an Excel spreadsheet, we'd have to choose which worksheet within the spreadsheet that we're uploading. If we have a header row, we want to make sure we specify that it exists. Otherwise, it's going to import that header row as if it was data. You probably get a problem with data types then. Let's say you have measures and you're importing a header as if it was part of data, then it would be a character. So next step, we want to select a target table to load this into. So for the target tables, we either want to make sure we specify if we want to append or if we will want to load into a new table. So when we select new, then we have to specify what the table name should be within the, which will be generated within the schema then. So obviously choosing existing will then append the data into the table. So we also have this manage table definition and data mapping screen. Here we can do some mapping between the source and the target columns. You should note that this is no ETL tool as such. So the application proposes a mapping structure automatically, which is just based on the names so that it maps correctly. We also have to select a key. So as we said, this is not an ETL tool. We can really only do one-to-one column mappings here. We wouldn't expect to do transformations from the flat file from within this interface. But we can, however, change the type, or we can rename or delete columns as we feel. So afterwards, it's a good practice to check the target table. It should now appear within the schema that we've chosen. So here we could then take a look at how it looks like. Maybe we have the right data, maybe we need to go back and change some data types. It really depends on how we have configured the file upload itself. So we've just briefly seen in this lesson then when to use flat file load functionality, also why. We've seen how to do it. We've looked at those windows there. So this is probably not going to be the most common type of day-to-day production method you will have of sourcing data into HANA. What we're then going to go into instead to see is the next lesson, which is about SAP Data Services, which is a proper ETL tool. So we'll look at, in this lesson, the main features of data services and what it actually is. We're going to describe how to use data services for our purpose to load it from ECC into HANA using ETL as the method. Now you've seen this slide before. We're now going to focus then on using business service data services to source data provisioning from perhaps ERP into HANA using ETL with data services. So what exactly is data services then? It's an SAP product for ETL, which is very versatile. It's a very good product in its own right. Let's zoom out into a higher perspective to get us an idea where data services is before we actually go into seeing how we can utilize it for HANA. So we're now going to look at a bit of an introduction to data services. To start doing that, let's imagine a typical corporate data landscape. We say it can be big, bad, and dirty. So most likely you will have seen these types of challenges just either in your own organization or at a customer if you're a consultant. We could describe data sometimes as siloed. And what we mean by that is that data can be scattered across the organizations in different ERP databases, even homegrown systems. You may likely even find different versions of the truth, limiting your ability to get a complete view of the business. Furthermore, it might be inaccurate. Data in itself is inherently dirty because things, they do change, and your business requirements, they continue to evolve all the time. So as a result, you do need ongoing maintenance of your data quality, both by the business and by the IT stakeholders. Data can be inconsistent, to the definitions of common business entities like customers, products, suppliers, material names, codes. It can vary from system to system. Therefore, it could be inconsistencies that data access alone cannot really address. You need a way to reconcile this. It could be incomplete. Another common data challenge is incompleteness. Customer record, for example, might be missing postal code, country code. Therefore, it might be unusable unless it's appendable with the correct data. It could be inaccessible. Connectivity can be a problem. Providing the correct connectivity will allow you to get access to the data in a enterprise system, but often this is only the beginning. The challenge really lies in how to unlock insights and potential from all the data sources. So your organization might have different ETL tools, or you may have heard of different ETL tools. So in this scenario, we see in this slide a typical IT environment where multiple information management tools from multiple vendors actually increase the complexity of managing information consistently. Each tool here will have its own metadata repository, own development environment, administrative environment, runtime architecture. So many of these tools, they're commonly used in an end-to-end solution supporting the requirements all the way from data extraction, transformation, cleansing, matching, metadata management. So this is where data services comes in, because data services, it's in fact 5 tools in one. You can do ETL, you can do data quality, you can do profiling, you can do metadata management, text analytics. So you can move and integrate enterprise data to and from almost any data source. And this, of course, includes SAP HANA. To target with extract, transform, and ETL, extract, transform, and load as in ETL capabilities, and improve data from any domain. You could cleanse it, enrich it, match it, and consolidate it. What's very important to remember with data services, and it actually has native integration with SAP. So this is not just HANA. This also includes ECC, ERP, BW, MDM, but it also includes integration with other data sources, as in third-party data sources. And just to give you an idea of where data services is in the marketplace, it's actually recognized as a leader in the Magic Quadrants for data integration and data quality. So, data services, it actually also improves analytics by helping out with data lineage. If you ever wondered where does a number come from in my report, data lineage function is part of data services and is directly integrated into the business object BI workspace of the BI end user. So by right-clicking on a number, users can actually choose to trace the origin of that figure back to where it comes from, how it was computed, combined, enriched, etc. And this kind of transparency, it would boost the true trust in your BI initiative and help users to make confident decisions, since they have full certainty of why a given figure is correct and what it really implies. Apart from that, in data services, there's also information steward that manages metadata and data governance. Let's now look more in particular about data services. So if we go from zooming out to zooming in, how do we use data services with HANA? Well, this is a process flow that we could follow. We could import the metadata of ECC and HANA into data services. Could then create a data services job that populates HANA. When we execute it, it will then populate the actual table. And like we did with the flat file upload, we want to preview the uploaded data. So to go and import a created table structure into data services, what we would then do, we need to create the table structure into the repository of data services. And with table structure, we mean table definition, column names, data types, metadata, really. So once we have imported the structure, we actually need the data itself. If we just want to do a simple one-to-one transfer, the minimum steps that we require would be to create a batch job within data services, create a data flow, which would show us how to do. We would show data services how we want to work with the data. And then we would execute the data services job and preview the records. So in data services, we talk about things such as data flow and a workflow. So what is that then? We kind of can see them as folders. So a job is a top folder, and then we have workflows. In the workflows, we have data flows. And we could mention that workflows are optional in this hierarchy. So here we can see a table which is currently being loaded with data services. We are monitoring the load progress here. We can see current row count is 4,000 of this Mara table. So note that you could also have used HANA as a source with data services and then loaded it into a different database. So data services is an ETL tool which is standalone, but you can use HANA then as a source or a target. Here we are viewing the uploaded data in the studio. Remember how we did it in the demo earlier. We did a select star. That's what we've done in this slide as well. Select from the table we've loaded with data service. So in this lesson, we've learned the main features of data services for HANA. We've been describing the process of loading data from ECC to HANA using ETL, extract, transform, and load. Now we're going to move on to the next lesson, which deals with the SAP LT replication server. So what's that? Well, after completing the lesson, we should be able to understand the architecture of the LT replication and its technical prerequisites. We should understand how to configure it, what we need to configure it, how the connectivity works to the source ERP system and the target HANA database. We should be able to configure data provisioning in HANA Studio and trigger an initial load, pause, resume, replication. LT replication itself, system landscape optimization, is used to consolidate and unite system. It could be system landscape that we want to harmonize and unify, maybe during mergers, acquisition, and SLO as a system landscape optimization. This is a proven technology that has been used in many projects. It's been used for over 10 years in several hundred projects. The LT replication server, it uses the SLO technologies. So it's a proven module in the SAP world. So let's look at some of the benefits then, because LT replication is actually suitable for customers who need real-time data, or maybe data replication that's scheduled. So it can be both from SAP and non-SAP sources. So with LT replication, we could migrate it into the HANA database. We could replicate it, and it could be sourced almost from any types of SAP system. All we need is SAP R3 4.6c and onwards. So that's the minimum version we'd need. And as we saw in the previous slide, it leverages proven SLO technology, near downtime, TDMS, SAP LT. Very fast to set up this replicator. The initial installation configuration can actually be done in less than 1 day. After that, fully integrated with HANA Studio. So if we look at the support matrix here, you can see that almost all the main databases are supported here. We've got SQL Server, Microsoft SQL Server, we got Oracle, IBM DB2, the Sybase, SAP MaxDB. For non-SAP source systems, the customer database license does need to cover a permanent database connection. And that's to a third-party product, which LT replication server would be classified as. So that's something you would have to look at together with the third party. So LT is suitable for multiple data provisioning use cases. It could be table-based replication, integrated into HANA Studio, real-time, both for SAP and non-SAP sources. It could be the replication engine for existing RDS solutions, which is on the first unit of this course, other ERP accelerators. It could be the replication engine for new SAP HANA applications accelerators. Okay, so we now know what it is, but how does it work? Let's take a look at the trigger-based approach here. Here we have a diagram of 3 systems. We've got a source system to the left, LT replication server in the middle, and the HANA database to the right. So we would have read modules in the source system that would access logging tables. These logging tables would be written to by database triggers in the source system. The LT creates triggers in the source system that writes to logging tables. Now these logging tables are specific to LT replication. So it's these logging tables that the read modules then transfer to the LT replication server with an RFC connection. So they go into controller modules, and then we have write modules that via a database connection would write into HANA. In this slide here, we see the LT server as a separate SAP system, but it could run on any SAP system with NetWeaver. So you could in fact install it on the source system should you want to. So the source system we saw on the left in the previous slide. Let's look at the details of this one. We would only want to select the relevant tables for database recording on the source system. Although, what we should mention here, even though that is the case, trigger-based approach, it doesn't really have a measurable performance impact in the source system at all. That's even with all the relevant changes recording into these logging tables. The replicated changes are then deleted from these logging tables, so you don't have to worry too much about space. Recording and replication is possible for all table classes, even cluster tables. The read modules will then collect these data changes and decluster table classes into a transparent format for sending to the LT server. Let's then look at the LT server, so the middle bit. LT server has the controller module. So this is the one that ensures mapping between the database structure of HANA and the database structure of the source system. It does give us some ability to do conversion. For example, maybe we want to convert dates into strings, strings into numbers, etc. Not really ETL we are talking about in general though, but it does have some possibilities to do such conversions. It does include features to manage entire replication process in a holistic manner. And what we mean by that is that it provides scheduling options to determine how often we want to replicate. So this controller module, it triggers then the write module. This is the module that writes through a database. As you can see, there are some system requirements for this LT replication server, but you can then even install it on the source system. So, LT is not actually limited to SAP sources. You could use third-party sources too, non-SAP sources. When you perform replication, LT first transfers all metadata table definitions from these non-SAP source system to HANA into a table called DB02L and DB02T. So from a HANA perspective, there on after, everything looks like you work with an SAP source. When table replication is started, the LT replication server creates logging tables within the source system. Only the read modules are created in the LT replication server. And the connection from the LT server to the non-SAP source system is established just like a database connection. There are some basic requirements and technical prerequisites on the landscape, but LT replication server can run on any SAP system, and it could be even from SAP NetWeaver 7.02, but we do need the SAP HANA 7.20 EXT. So Solution Manager 7.1 or the source system would be usable if you wouldn't want it as a separate system, provided you have that installed. Now, for non-SAP systems, there's even less prerequisites. But you should remember that for a proprietary database, you will also need the appropriate database user permissions in the source database. But this is not always the case, depending on the type of, let's say it's an ERP system, CRM system, or trading system. You would need to have the right permissions in order to create the connection here so that SAP LT can read from it. This slide here, it's showing us the configuration and monitoring dashboard of the LT server. So this screen will be able to provide different status information. For example, triggers are active, job monitors, status load. Are there any error alerts with replication? What's the system connection? Could also be statistical information. We can see the lowest, highest average speed rate of replication. So this is like our control panel of the LT replication. So if we want to set up replication in SAP HANA, we have a couple of steps to follow in HANA itself, in the HANA Studio. We want to select the source system that we've defined in the LT replication server, and then we have these buttons: load, replicate, stop replication, suspend, resume. This is all part of the HANA Studio. If you look there on the left-hand side, you will see the quick launch tab there. Here, down here, you can see where to use the load buttons, the replicate button, stop replication, suspend, and resume. What we want to do is to select the relevant tables that we want into HANA. So data replication is a one-time event. No logging tables or triggers are created in the source system. When we replicate, it starts an initial load procedures and delta replication as configured on the LT replication server. Stop replication would stop the replication. We're going to see a little bit more in detail about these options later. Here we can see that the stop replication, there's a difference between stopping it and suspending it. Because when you stop, the table will be dropped and the initial load must be repeated because delta recording was deactivated for a certain time. Changes might not be recorded. So in any case, you want to pause the delta replication, then you should use suspend and resume. It's different to understand the difference between those two options that you have. Worst case scenario, suspend and stop only if you know you're not going to need it anymore. We have multi-system support here. You could have multiple source systems replicated. They could be connected to separate HANA schemas on the same HANA system. You could also have multiple source systems connected to even separate HANA systems altogether. Could even be the same schema or could be different. You could also have multiple source systems connected to the same HANA system, even the same schema. The same LT replication server could even have the same SAP source system connected to separate HANA systems or to the same system with a different schema name. So up to 1 to 4 HANA systems is supported. Let's look at the summary here of LT replication. So the concept is based on very proven technology. It's used in SLO technology for near zero downtime, TDMS, etc. It's used by hundreds of customers with large databases. It does provide it with a holistic concept in that we can use the HANA Studio to control it. So LT replication server is a great solution if you have HANA customers who need real time. That's the key takeaway from this. If you want to source real time, replicate into HANA real time, you will probably want to look at LT replication. We also have another possibility here of providing data in HANA. It's the direct extractor connection, DXC. DXC. So this lesson will deal with the DXC. After you've completed this lesson, you should be able to explain an additional data acquisition technique newly introduced into HANA for working with the business suite systems that has this possibility. Let's see what it is. So DXC is a direct extractor connection for HANA. And if we look at SAP Business Content data source extractors, these have been available for many years as a basis for data modeling and data acquisition for business warehouse. And now with DXC, these SAP Business Content data source extractors are available to deliver data directly to HANA. DXC is a batch-driven data acquisition technique. Should be considered as a form of extraction, transformation, and load, as in ETL, although these transformation capabilities are fairly limited in this sense. But DXC, it's simple, and it provides low TCO. It reuses existing proprietary extraction, transformation, and load mechanisms that is built into SAP systems. And this is done over a simple HTTPS secured connection to SAP HANA. So you don't actually need an additional server or application in the system landscape. With this, it's even got changed data capture, so you could handle delta loads. Thereby, you get an efficient data acquisition in only bringing in new or changed data into HANA. Let's look at an illustration on how the DXC concept can be realized. An SAP Business Suite system is based on NetWeaver. As for NetWeaver version 7.0, Business Warehouse is part of NetWeaver itself, which means a BW system exists inside Business Suite systems, and with this we mean ERP ECC 6.0 or higher. So this BW system is then referred to as an embedded BW system. With the default DXC configuration, we utilize the scheduling and monitoring features of this embedded BW system, but we do not utilize its other aspects such as storing data, data warehousing, reporting, or BI. The DXC extraction process essentially bypasses the normal data flow and instead sends data to SAP HANA. If you look at the diagram here, you see the default configuration of DXC. An in-memory data store object, IMDSO, is generated in HANA, which directly corresponds to the structure of the data source you are working with. This IMDSO, it consists of several tables and an activation mechanism. This active data table of the IMDSO can be utilized as a basis for building data models in HANA. This can be attribute views, analytical views, calculation views. So data is transferred from the source SAP Business Suite system using a HTTP connection. So generally, the extraction and load process is virtually the same as when extracting and loading into BW. You rely on input package, scheduling, data load monitor, process change, etc. So they're all well known for operating business warehouse. But DXC, it doesn't require BW on HANA. And also, with DXC, data is not loaded into the embedded BW system. Instead, it's loaded directly into HANA. So to summarize, the DXC utilizes the data source extractors that exist in SAP Business Suite systems. It utilizes the embedded BW for extraction. It uses the embedded BW system for monitoring, and it's available for Business Suite system based on NetWeaver 7.0 or higher. Let's see a real-life example here of how it could look like. Here at the bottom, we have a sales order here. It goes into via update methods into the Delta queue. We're still on the ERP side here. Then we go into this transfer structure. We will have a data source for transactional data, which is then redirected from the embedded BW into the activation queue table. We're now on the HANA side here. And then finally, we see that as an in-memory data store object, IMDSO table. After this, we can start utilizing this table for modeling. So if you want to see a little bit more about DXC, you probably want to take a look at our HA300 training, which does provide some more detail. So in this lesson, we've learned about the DXC. We've learned about additional data acquisition technique, which has been added to HANA. What we're now going to see is a little bit about data services. We're going to see a demo on how to load data in HANA using data services. So let's move to the demo. So here we have the demo system. We now want to start data services. Again, a big client, which is installed here. In this folder for data services, which we start the designer, which is the main component. And then we want to log in to a system, log into select a repository. So the repository basically holds our metadata that we create. We select one of the repositories there. After we've done that, we're inside data services. What we now want to take a look at is how does this client work? Well, we've got a project area here to the left. We've got a local object library. In this local object library, we can see different types of projects which we can bring up to the project area. We see the amount of batch jobs that we have created. Remember how we said this hierarchy, we first got the jobs, got the workflows, got the data flows. But before we do anything, we do need to decide where do our source system and target system live. This will enable us to actually create a project, a data flow, transfer some data. Okay? So in this local object library, we are going into the data stores. We're going to set up a new data store. I'm going to right-click here. I'm going to say new. I'm going to call this data store my ECC. So this will be an ECC system here. I'll select that it's a SAP application, source system, got a server of ZMCT 0. Got a username and password. I'll make sure I've got the right client, 800, system number 00. Okay. So now I've defined a data store for my source system. I now know where to source data from. I need to put it somewhere as well. We need a target system. We want to load it into HANA. I'm going to create a new data store. I'm going to call that my HANA. And this is a database as well. The database type, SAP HANA, HANA 1.8. Got an ODBC connection to a HANA database here. I have to identify myself. So here, we now have two data stores, ECC and HANA. What we now want to do is to import the metadata of an ECC table. I'm going to right-click on tables here and say import by name. I am going to transfer the TCAR table, so it's exchange rate. You now see that appearing under the table. Look at this definition here. It's got several columns, mostly characters, some decimals, but holds the actual exchange rate. Okay, so let's move this table into HANA. How do we go about doing that? Create a new project. Here we're going to create a new batch job. And we sort the TCAR table. Now, when I've selected in this project the batch job, on the right-hand side here, I can see what's in this batch job. It's currently empty. I'm going to put a data flow in here. Call this DS for data flow, TCAR, HANA. Okay. Double-click on it to go into it. Again, it's blank because there is nothing in here. You see the hierarchy here. I can now graphically show data services how the flow should be. I'll go ahead and drag in the TCAR table here as my source. I am going to do a query on that table. So with my tool selector, I'm choosing the query transform. Bring it here. I can connect, see how this hand turns into a hand which holds a pen or a crayon. Connecting the TCAR table to the query. Go into that query. I want to query every column of the source table. So I'm going to select every column, put it into the query. I'm going to come out of it. Now we've sourced data in the query. So we want a table in HANA to be loaded. I'm going to create a template table. That means that HANA is not only going to load the data in append mode, but it's actually going to create the table as well. I'm going to call it student 16 TCAR. Owner should be student 16 as well. Okay. So here I will go ahead and connect it. And because this is a template table, I said it will also build the table. This means anytime I run this job at the moment, it would actually rebuild this table. Okay, I'm going to go and save this job. The changed objects that I have is the job. It's also the data flow. Okay. What I can do is also to validate this job. No errors found. Isn't that good? Okay. Now I want to run this job. I've only created the definition of the job. I also want to execute it. I'll right-click on it. I'll go to execute. Okay. Many settings to set here. Remember, data service is a fully fledged product which has been around for many years. So we are now going to load this, start this job. Here I can follow what's happening in data services. I go into the monitor here. I can see how many rows have been loaded. So 347 actually stopped now. It's already done it for me. What I want to do now, I want to go into HANA and see that this has actually been loaded. So let's start. Start in memory computing. Remember, we have created this student 16. Going to go into student 16. Going to see its catalog. And I'm going to look under its schema. Should be able to see here under the tables. Excellent. Let's take a look in there. Table definition looks good. Looks like in the ECC system we've achieved what we wanted there. Let's see if we have data in there too. Great. Remember what the other method is that we have in order to see data of a table? Yes, I could write SQL. I'll go ahead and right-click on the system, go into SQL editor, and do a select star from my table. I'll drag it in so I don't have to type it. Yes, so you see we now have this table in here. I could now start to use this either with clients or I could do further modeling on it. So you've now seen how to load data into HANA with data services. So this concludes this demo and also this unit.